You want to IO Academy. Let me not forget. Just IO Academy. So today we are going to be treating the topic, though by the grace of God we are still going to move to determiner, but I still want us to touch that partial differentiation. So maybe if you still have time, then you can move to determinant. So we have partial differentiation. So all of us, we are aware that differentiation is finding the derivative of a function. The word differentiation is what? Finding the derivative of what? Of a function. Now, let's say we have something like this. Let's say we have f of x is equal to x squared plus what? 2x. Now, this is a function. Now, function of x, it means that what we are dealing with here must be x. That's what this thing is saying. Is that clear now?
Yes.
Okay. Let me make it more simpler. Okay. So if I have female, it means that I'm talking about only female. Yeah. So the function of female, I will not say female raised to power 2 and what? 2 what? Female. So what I'm doing is that I'm only dealing with what? Female here. Is that it? So anything other than female is not recognized. Is that it now? So now we have f of x is equal to x squared plus 2x. Now, f of x is talking about the function of x. Everything here must be based on x. So that is differentiation. But partial differentiation, we can have more than what? It's also the same thing as finding the derivative of a function. Is that clear now? Finding the derivative of a function, but that function may have more than one independent variable. It can be 2, it can be 3. I've seen I've seen one that has 3 independent variables. Is that it? I've seen one that has 3 independent variables. And I told us that this f of x now can be written as what? Y is equal to what? X squared plus what? 2x. That is to say, this y depends on what? X before the value can be what? Can be obtained. So in this one now, this one, we have that what? We have that y is a what? Is a dependent variable. That is, it depends on what? X. And s is independent. I use parent as the case study. That is, I use like analogically I use parent and what? And their children. I'm saying that the children depend on the parents for them to what? To survive. So now I say now, in fact, we can also have that x is equal to y squared plus 2x. Oh sorry, plus 2y. What does that mean? It means that what? X is a dependent variable. Y is what? Is an independent variable. Such that what? X is outside, but this one what is inside. Because we can get x here, it's as if this one and this one. In this case now, y is the one outside, but x are inside. So y that is outside is depending on those ones that are what? That are inside. And this one also another function. X is outside and y are inside. So x is a dependent. It's depending on what? On what? Those ones that are inside. Is that it now? Okay, you have a question. What is the question?
So before you continue, these dependent and independent variables.
Yes.
If you are solving stuff like simultaneous equation, you're going to see questions like maybe x plus y is equal to 20.
Yes.
Now, that equal to 20, now the 20 is already known.
Okay.
Can you still say because the 20 is outside is a dependent variable or independent?
Is that 20 a variable?
Yeah.
No.
It's constant.
A constant. So Answer your question. Call that thing again you called now.
That's x plus y
X plus y
equals 20.
equals to 20. So that means that this x can come to and y is
Minus x.
Okay.
Is that it?
Yeah.
Right. So now we are moving to a partial. I will have this z is equals to xy plus okay, let me just firstly give something like this. Let me just say it's equals to x squared and y cubed. And then let me now put plus y squared. So I have z is equals to x squared y cubed plus y squared. Now I told us something that we have what we call constant term and what? Constant factor. Constant term and constant factor. Okay, constant term is just a term that is constant. I used to say it does not have a relationship with the other word, with the other variable. Exactly now. It's a term that is standing alone. Look at this one now. This is a term on its own. Exactly now. This is a term on its own. Is that it now? But when we're not talking about constant term, we are talking about that term they are not considered at all. Okay, let me make it more easier. If I have male to this place, but this function is talking about what? Female. Do you understand what I'm saying now? So this male now is a constant. It's a constant term. Is that it now? Because we are not considering what? This one for now. Do you understand what I'm saying now? Because we are talking about what? Only what? Female. Only female. So even if you want to get female here, it will be what? Female raised to power what? 0. Because anything raised to power 0 is what? 1 times male is still male. Is that it now? Do we get it? Yes. So constant term. Now this constant variable now. So if I work on, like if I'm differentiating, like I'm saying the z and what? If I'm saying the z and what? The x. What does that mean? It means that I'm working on what? On z and I'm working on what? On x. So at that time, I'm not working on y. Because this thing is saying that the z over the x. So anything other than x, we are going to treat it either as a constant term or a constant factor. So what are we even saying about constant term and constant variable? What is the meaning of this thing, everybody? You can see that this x and y are joined together, then it becomes a constant factor. Is that clear to you now? It becomes a constant factor. At that point, y will become a constant factor because it's joined to what? To this x. But at that same point again, this one that is standing alone will become a constant word 10. Let me say it again so that it will enter our brain. I'm working on the z and the x. At this point, I'm not talking about y. So what will now happen to y? This y here will become what? A constant word factor. And this same y here, which is standing below with that x here, will become a constant word. Yeah. Constant term. So we are going to treat it as 0. When we differentiate, it become what? 0. Is that it now? Look at this one so that you'll be familiar with what I'm saying. So we have 2x plus 2. So if I differentiate the y over the x now, differentiate this one, we give what? 2 plus. If I differentiate this one, 0. Do you know the reason why it's 0? Because it's a constant term. It's a constant term. Because there's no x at the back. I'm differentiating. I'm not working on 2. I'm working on x. So this will become what? 0. So now when we differentiate x here, so let's differentiate this one. If you differentiate this one, so this is x squared. If you differentiate x squared, it will give us 2x. We minus 1 from this one. Is that it now? So it become 1. Abi? Yes. Okay, we now have what? 2x. So we have our 2x. But we are not, this is a constant factor, we are going to just put it back. We are not working on it. Just put it back there. But this one that is standing alone is a constant term, not a constant factor. So it becomes what? 0. Then we have 2x, y cubed as our answer. So we are done with it. Any question from that one? Okay? Now, if you are now working on the z over what? The y. The z over what? Over the y. It means that at this point, we are what? We are working on what? We are working on y. Is that it now? We are working on y. So what does that mean? Let's come to this one, this question. So this x now, we are not working on x there. This x will become what? Is it a constant term or a constant factor? It's a constant what?
Factor.
It's a constant factor, not a constant term. Do you understand what I'm saying?
Yes.
It's a constant what? Factor, because it's joined to y. So this x is joined to y. It's a constant factor. But if it is standing alone, but this y now is not a constant. Now it's either a constant term or a constant what? Factor, because we are working on y at this time. Is that clear? And we also have another x here. That x will become a constant term. Are you getting?
Yes.
Okay. So let's bring this one. We are going to bring it back. That's a constant what? Factor to x squared. Then differentiating this one will give us what?
3y squared.
Y will move from this one to give you what? Squared. So 3y squared plus. When you differentiate this one, because we are working on y, is that taken out? So it give you what? 2y. You remove one from this one. 1 again? 2y. Is that taken out? So 2y. Look at this 3 here, you can bring to the front. It will become 3x squared y squared plus 2y. And that is our answer. So, any questions on this one? Is there any question? Alright. So, now, we can still have this thing, this same thing. Hello, listen everybody. We can still have it in second order, that is this one to be raised to power 2 and this one raised to power 2. So we can have that as well, the square z over the x squared. So the square z and what? The x squared. Now look at it now. If you look closely, if you open your eyes very well, you will see that this one it appears as if it's occurring twice. Is that clear to you? That is, if you say x times x, you give you x squared. Yes. Okay. And if you also look here, it's as if this d, it's as if it's extinction what? Twice. So to now look at d, the z over what? The x, sorry, the x, the x, dx. Is that clear to you? So listen everybody, this d now, look at this d and d. If you multiply together, what does it give? This square, give d squared, right?
Yes.
Okay? D and d, give d squared. Now this is dx squared. Dx squared, then dx times the x, what does it give you? Yes. Dx squared. So we can just take this one separate. So it will now become d over the x into what? The z over what? The x. Now we have d over what? The x. In this place, we've obtained the z over the x as what?
2x
y 2xy cubed. Alright. So now here we are differentiating what with respect to x. So y will be treated as what? Constant what?
Constant factor.
Constant factor. So we are going to have, so these two here, we put it back. So you're differentiating this x. This x here is what? So x raised to power what? 1. So you carry the 1, you remove 1 from this one. Is that clear now? So now, So x will now be raised to power what? 0. So this one will now give you what? So 1 times 1. 1. So 1 times 2, these 2 here. So let's just say times 1. So this this y, we're just going to what? Write it back. Is that enough? Because we are not working based on what? Y. It's only x. So everything now become what? 2y raised to power 3. Is that taken everybody? Yes. Okay. So let's move to the next one. Now, let's say we have the square z over the x, the y squared. It means that it's appearing like this, the over the z over the y, sorry, and then the z over what? The y. Is that taken out? It's appearing like this. But if you multiply this d and d, it will give you square. If you multiply both in here, like this one and this one, it will give you this one. So now we now have d over the y into the z over the y. What do we have? Well, call it
3x squared, y
3x squared,
y
y squared
plus 2y.
plus 2y. So here now, we are working on what? We are working based on what? With respect to what? Y. Right? Working with respect to y. So at this point, x become what?
Constant factor.
Constant factor. Thank you. So it should now be what?
3x.
X squared. When you differentiate this one, I need to write 2y. So when you differentiate this one, what do you get? You give this 2. Do we all agree with that?
Yes.
Okay. Look at this 3 and look at this 2 here. When you multiply together, what do you get? 6. 6. X. This is x squared. And what? Y plus what? 2. Thank you. So then, when we can still have something like this. The square z over the x and the y. Is that taken out? Yes. We can do the same thing as the square z over what? The y, the x. Is that taken out? Alright. So, now I will work this one and work this one. I will not give what to work this one now. Please. Then we will do my class part. So let me firstly work on this one. This one. So I will have the square z over the x, the y. Have it? So it will now become the and what? Over the x into what? The z over what? The what? The y. So this one will now be d over the x into, we have already have the z over the y here as well.
3x squared.
Y squared.
Plus 2y. So when we are differentiating it with respect to x, at this point y will become what? This y will become what?
Constant factor.
So this one will become what?
Constant.
So we now have 3. Differentiating this one will give us what? 2x. This one we are going to write it back. What is the reason why we are writing it back?
Constant.
It's a constant factor.
So this one become what?
0.
Thank you very much. So this one times this one, what do we have?
6x.
We have 6x y squared. So this is what we obtain using this one. So let's use this one to give us the same answer. So we have the square z over the y dx. So now we have d over dy into the z over what? Dx. So we have d over dy into, now we have the z over the x. What do we have with that?
2x y cubed.
Y cubed. So we are working with respect to what? Y. So x will become what here?
Constant factor.
Constant factor. So differentiating this one will be, what will be?
3y squared.
3y squared. If you multiply this one and this one, what does it give?
6x xy squared.
So this is it. You see that the answer you got here. See this in motion. So now I'm giving this work to you. You do it the way I did my own. Okay. Thank you very much. Thank you.